Today's session, because we are going to keep it restricted to one domain of AI specifically, and that would be deep neural nets, and specifically in that computer vision. So let's begin, and any questions, please feel free to ask. Before we jump into what AI means for any one of us, and there has been a extension of umbrella of definitions across different technology providers as well as nations what they perceive as AI. But it's important to understand that the word VUCA, which we hear all over the time, that the world is volatile, uncertain, complex, and ambiguity, and this is happening. This is shaking not only our society, world, but reconfiguring our every system. And it's just not because of COVID. It had already begun. This era of recalibrating our societies had begun a long time back, and all what you're seeing is that COVID has just accelerated it. But what exactly is VUCA? How would you quantify VUCA or measure VUCA? Any ideas, guys? That how would you quantify VUCA? Maybe I'll minimize my screen so I can see what others are typing also, if you can. Any ideas? How can we quantify VUCA? No ideas as such?
No idea, sir. Please
okay, I got one thing, I guess, on the thing. Okay, no issues. So, predominantly, volatility, uncertainty, complexity, and ambiguity is a combination of couple of factors. One is systematic and other is non-systematic factor. So obviously, one is that we are seeing a geopolitical situation globally play out between the world domination powers. But if I go a little step below that, and then you see that in the realm of society and business, there are three more variables which are also acting, which are really relevant to us in our day-to-day lives. One of them is the technology variable. So we have seen that today, any business you open or any industry you go to, there have been explosion of technologies, and it's not that you can do with one or the other. For example, if you just look at here at a technology, dimension, you would realize that there are 30 technologies mentioned here, right from AI to Internet of Things to 5G to adaptive nano printing to 3D printing and quantum computing, and the list goes on. And all of these are changing at a second order derivative, meaning there is an acceleration on the rate of change. This is something which we have never seen in the history, what we are seeing in the last 3-4 years, the acceleration on the pace of change. But there are two more dimensions. The two more dimensions that are occurring is the product and the market dimension. So earlier what used to happen, 17 years back or 18 years back when I began my career, and some of you are more experienced than me, but when I began my career, what had happened is we used to make a product and we could milk it for 5 years, So product banaya or 5 saal alag-alag market में job. And either the market access used to move of the product access. Today, we're sitting in a world where both the market, product, and the technology, all three dimensions are moving and moving exponentially. What does this mean actually? This means that whether it is at the organization level, at the nation level, or at the individual level, so reskilling yourself and adapting to change has become a paramount need that we all have to live up to. Just to give you a context, 70% of the world's assets today are actually, the GDP assets which people invest in are actually obsolete. Because the life cycle of an asset, specifically digital assets, and the intellectual property which corporation organizations today have reduced from 5 years to 18 months, and it is now getting even lesser than that. So what this innovation acceleration leads to? Obviously, if you look at a timeline, if you could solve, let's say, we took out desktop computers and the design stayed the same for years and years and years together. Or let's say your telephone, 30, 40 years there was no change, 50 years there was no change, it looked the same. Today, every 2 weeks, we are seeing agility that newer features are being launched, whether you're talking about video streaming, whether you're talking about telecommunication, whether you're talking about optimization of 5G networks, whether you're talking about Internet of Things or vehicle-to-vehicle communication. So, how do we as humans comprehend with so much of noise, so much of information, and so much of rate of change? This can only happen if we keep adopting ourselves to newer paradigms. And so, what is more important today is understanding information, understanding patterns, and able to make sense of it. Only one more thing I want to add, although this webinar is restricted to AI, and I wanted to contain it, but I wanted to give a pre-filler. Only AI or learning data science is not going to cut out for anyone. You got to be multidisciplinary, and you got to have the ability to look at the world from different dimensions, whether it is from design perspective, whether it is from data perspective, or whether it is from a systems thinking approach, which is a larger and a more generic context. So if you now see what they are saying, if you look at World Trade Organization and World Economic Forum, they're saying that a lot of newer technologies and a lot of new markets, and market doesn't mean only physical markets, but it can be newer business models of doing things and new products are being launched. That means the barrier to entry has reduced. Information symmetry is there. It is no more asymmetric. But having said that, the world profit pool of the GDP, global GDP profit pool will reduce from 9.8 to 7.9%. And can someone give me any idea, rough guess, why is this so? Anyone idea that why do we think that the global profit pool will reduce? Even though when there is a lot of explosion of new startups, technology, somebody did write something. Machines are replacing humans. Uh, yes, you can say machines are replacing humans, but there is something more to the story. Even though the playing field might have leveled, but at the same time, the competition demands you to not only build computational thinking, understand patterns and systems thinking, but it also to build multi-disciplinary skill sets, not just specific domain knowledge. This is the precursor I wanted to say before I discuss, what exactly AI is. And now I will jump to artificial intelligence. So there has been a lot of talk, if you look at globally, what AI is, what AI means, and AI organizations. We do understand that it is an essential tool to automate and to increase the productivity. But essentially, AI, if you look at the larger umbrella, right from statistics to machine learning to deep neural nets to remote process optimization or RPAs to chatbots, it could mean virtual assistants. It could mean a lot of things which encompassed into one. However, there has been in the society a fight that everybody is trying to look at and distill this concept into, is there something called a generic AI? And general AI means one single machine or one unified model which can solve all the needs of of a humanity. Something which is conscious enough and something which can read itself, adapt itself, be creative enough, understand different dimensions of what it could be to be called intelligent. So if you look at this over here, this diagram, you see that there's this emotions. You intelligence as human, emotional intelligence. And you have sensory, then you have emotion, cognitive. We are self-aware of a lot of things. and we have intuition or perception, and we have language. And based on these, we can do a couple of things. So if you look at the cognitive side of it, we can identify labels, we can forecast, we can predict patterns, we can adopt and evolve. But at the same time, we creativity. We have something called ethics, and we can understand ethical dilemmas. We can build empathy. But if you look at AI today or any machine, it can't do all of this. And we are very far that we are near to that transformer age where this is possible. No, sorry to say it's possible. Today, AI is more localized to the task we do, and based on the task, we train the models or we do feature engineering based on the branch of artificial intelligence you choose. So we are more focused on, let's say, cognitive. So we can identify labels, we can do forecasting, we can do anomaly detection, we can do adapt and evolve. So, for example, we use reinforcement learning where there is an agent, and that agent is given certain tasks or missions, and then rewards and punishment. So it can adapt and evolve. The AlphaGo, when it was defeated, it was by a reinforcement learning model. So what I'm trying to tell you here is that general AI is too far off. What and its subfields, what they all address, right from Bayesian techniques to statistical models to deep neural nets, they all focus on what we call the weak AI or narrow AI. So narrow AI is we take the set of data and we try to make a sense of it, and that in that specific realm or domain of prediction or detection or classification or clustering, the models far today beat humans in their accuracy. So typically, guys, if you are a little fast, do let me know. I'm just trying to, go set the pace. And if there are any questions, you please let me know. So Gurpreet did mention, yes, I'm sorry, I saw it now. Because of volatility and uncertainty, you mentioned lower self-lives and competition. Absolutely, Gurpreet, that's very true. And that also means that we as individuals have to adopt our to the environment at a much faster rate. And that doesn't mean that we always say that this is a cognitive economy, but I personally believe, and may be wrong here, but this is going to be an imaginative economy and more bigger than it's going to be an imaginative society in the next 5 years. So the ability to create, imagine, fail fast, and having that kind of muscle is more important. So, what is the kind of data we deal with? So, let's simplify things. Ultimately, science is about simplification, and that's where the beauty is, right? And if you look at any algorithms in the world, if you look at any kind of a data in the world, you can just classify them under these 6 or 7 things. One is that you might see a spatial shape, or an image, or you might have a video, you might have audio, you might have numbers, you might have text, and then metadata. Metadata is data which tells something about the data, right? So, for example, let's say if I am streaming you a video, then it is saying who is streaming video to whom, how much they bought it for, which movie are they seeing. So that is data over data. And then graphs is technically a data structure, but we still formalize it as a form of data because its visual representation is very powerful and gives you certain information which otherwise we can't comprehend. For example, if you want to do a drug discovery, so how does a drug discovery work? You take a molecule which binds with certain receptors in your body and it follows a path. So now the path it follows to reach the receptor and bind to your target site can have millions of ways of going about it. So obviously, if you look at visualize it, it's going to be like a graph. Similarly, if you look at black money today being caught, so how AI systems do it is actually they make a graph out of it. A gave money to B, C, D, E, F. B, C, D, E, F gave to another 10,000 people, and then it got routed back. The whole network collapsed to another few set of people, which again report to E. Now that power we didn't have few years back, and that is why graph networks have their own story to tell, and it has become very important in fields of medical, to banking, and you name it, in every other field. In fact, the biggest use case is to make knowledge bases or ontologies. So uh, for computer vision, I am just setting the some part of the tempo, and then after another 10 minutes, I will jump to computer vision. So definitely, we deal with two forms of data. I think we all know about it: is structured and unstructured. Structured, I mean, your more tabular form. For example, हमने table में columns and rows we make it and we say this is how it is going to look like. But today, the information and the way the brain uses digital paradigm is more non-linear. It's more about flow. And in the flow, you don't make tables and columns. To be more creative, you use audio, use video, you put post on Instagram, somebody's liking, somebody's disliking. So ultimately, there is a varied, rich and varied sets of data that is being created. All of this structured data is right now at the bottom of the pyramid. So today you can just see all the iceberg. You can just see the structured data, and some in the unstructured people try to parse PDFs, presentation, social media posts. But there is a whole plethora of unstructured data that is there that needs to also be processed. And this is one area where AI has been really helpful. So when did people started talking about artificial intelligence? And this graph starts from 2010 as a timeline. But even during the World War, right, when Alan Turing made the Turing machine, it was to break the ENIAC code, and computational thinking and computational logic actually had taken over in the world. But from there on, it was 1950s and 60s when Jeff Hinton, who started looking at deep neural nets, which we will cover, where we started seeing that how we could mimic a human brain and human neurons, where things started being conceptualized and being constructed. But the AI beating humans was not by what I'll say by design. It was by a luck. And I'll tell you the story about it. It's very interesting. So what happened is that there was a gamer who was also a artificial intelligence student, and he was participating around 2011 or 12 exactly 2012 or 13, which is fairly recently, in a competition to create an AI deep neural net model. The problem was he brought his gaming laptop because and then he realized that he had not brought his normal laptop which actually has a CPU. So he had to train his model on a GPU. Now, why GPUs are more important than CPUs for deep neural nets also is because there is lot of matrix multiplication that goes, and for that linear algebra competition, matrix multiplication, GPUs can do parallel because they've got parallel cores. They can do parallel competition unlike CPUs. And by chance, he realized that his models were being trained much faster, and rather than days, it is even take. There have been some models which have been trained. It has taken years. The latest NLP model of GPT-2, GPT-3, it took them 48 days on from around 1,500 GPUs, and it cost them $7 million one training cycle. Now imagine if you had to do it on a CPU, it would have cost you few years of computation power. So it was around 2012 and 13 we started showing that people started getting excited once they start understanding that GPUs are there. And then ImageNet 2015 actually took overpowered human performance, and it was far more superior. That means detecting objects, detecting images, see what does the image convey as an information. Now we have seen after 2017 and 18 that even language processing, the processing of documents and summarizing them have also taken over. So obviously that I'm going to skip a few slides because otherwise the topic is very vast. But yes, we started earlier on. We should do basic regression analysis. Take some x to x10 for example, and try to predict the y. Right. So independent and dependent variables, and the y which we are predicting that there is an error rate, and we used to do there were certain methods, whether getting linear regression, logic regression, or polynomial regression, and we used to calculate the loss or the error, maybe like mean squared error, and then try to see which variable works and which variable is actually influencing the prediction. The other kind of problem which we typically used to encounter is classification, whether it is a dog or a cat, and you can do this even without you can even do this with statistical modeling. It is totally possible today, and I'm going to show you some tricks it used to be done. And then obviously machine learning came along with not only regression, then we had clustering. And clustering is today one of the most important things in the world because, and I'll tell you, I'll come to that, because in classification, example, I have to classify a brain tumor, or I have to classify whether the text is, whether the customer is irritated or not. So what is the sentiment? All this requires you to label the data. And labeling data can be expensive because to reach an accuracy of 80%, you might just require a few thousand samples. But if you want to go to accuracy of 95, 96%, you might require even a million samples. And that's where the game actually creates a barrier to entry, and it is unfortunately undemocratic. So the likes of Google and Amazon, who have lots of data, they can play around. And the cluster, on the other hand, allows you to not do anything. Just look at data, and it clusters data together based on a probability distribution or distance, and take it from there. So there are a lot of methods like Gaussian, hierarchical, and K-means, where you can cluster the data. Just to give an example, for example, you want to do customer segmentation. So typically people used to segment customer based on, if I just put on a notepad, for a second, people used to say age, then taste and preferences, buying pattern, area, profession, and they should say, okay, I've clustered based on, I've labeled this person as, if he or she purchases so much, and gender, and they purchase at certain frequency and a certain recency, then I will say, taking all these variables, I'll say, okay, maybe this person is a mid segment for me. Just an example. But today, what we do, we don't do this. We can create hundreds of sub-segments because we combine this data with unstructured data. What is the unstructured data? Your Facebook personality. We do personality analysis on it. We take all your tweets and scraps and can do a big 5 personality analysis. Then we take images that you post and we can understand your taste and preferences. Now, all this metadata, all this unstructured data is used, is passed by an artificial intelligence, maybe a deep neural net model, or I can take all of this information and all of these variables and cluster them. So there can be 4 clusters, 5 clusters, 20 clusters, where people of similar behavior, personality, likes, dislikes, taste, preferences, in images, what brands they wear, what colors they wear, I can cluster them accordingly. So just to give you another context over here, if I just show you here something called fashion, MNIST. This is something very interesting when I talk about unclustered. Because let's say these are cluster of data, sets of data where you see leggings, cardigans, jeans, shoes, and you see this. This is actually a cluster of data across X dimensions, and the nearest neighbors are the most likely combination which people are buying today. And this is exactly used today when the recommendation engine is being prepared by Amazon. So they use unstructured data and they make it into clusters, they use graphs, and then they use structured data. So multiple things to actually do information as to what is happening. Now that we have discussed, that what exactly is like unsupervised learning and what is supervised learning, we also have reinforcement learning, where we reinforce the concepts using rewards and punishment, like I told you, AlphaGo. But today we're going to discuss about deep neural net. And deep neural net is more like a baby. which falls under the gambit of supervised learning. So supervised means I have to feed it some data, and I have to give it, and I will label the data which is out. So I feed an image of a spoon, and then I label it as a spoon. I feed in the image of a cat, and I label it as a cat. Now the beauty is this must in and this is a little counterintuitive for developers, not for other people. Developers always used to have the control over the logic. So, they love to create that mathematical equation, that algorithm. The problem is the error rate is there and there is a bias in an equation. Even in an equation of E is equal to MC square, uh, uh, there could be a E is equal to MC square might have a 0.00000001% some error, and because mathematics is about approximation. It's never about absolute values. That is why at science we always observe a phenomenon and we keep improving our iteration by it. So approximation is a personality of deep net. Why? Because what they do is they take all these inputs, and these inputs can be in millions. They take all these inputs, and then what they do is they will, after you've given it a certain output, they will try to predict that output, and if it is wrong, then they will adjust it. So it is by trial and error, and I'll come to it how it happens. It is by trial and error deep neural nets are being formed. So what happens is the algorithm or the how it is giving the weights, we really don't know. That's a black box. We know how to make it, but which neuron is being given a weight or which pathway is being given a more weight than the other, that is still a hidden information. So how did deep neural nets come into picture? We did talk about it was inspired by to mimic a brain, but obviously our brains are far more sophisticated and complicated than just a simple deep neural net. However, in our brain, we have neurons, and for example, you get up early morning. When you get up in the morning, what exactly happens is that you would notice you keep a bucket of water next to you, and if you dip your feet and you walk every day, you will taste because conscious habit, you are walking nearly on the same, maybe with a standard variance of 15% or 10%. Because the similar neurons are getting fired and they're used to it for a certain task. And obviously, similar concept is trying to be mimicked brain by a deep neural net. Where let's take an example of a simple regression analysis. In a simple regression analysis, what we did is, let's say these are X, these are the X, and these are independent variables, and dependent variables is which segment should I classify this in? Which segment I need to classify, and this is Y. This is a predictor. I have to predict this variable, right? Now, I take the previous information, and based on this previous information of all the X's, the Y is predicted, and particularly the formula Y is equal to, I'm just writing a basic formula which we all have studied. Y is equal to mx plus c plus epsilon is the error rate, just to put it like this, right? And some error of approximation mx plus c. Now this, if you have 10 mx, so this will become mx1, and this will be maybe mx10. So 1, 2, 3. This is complete series is going. So essentially, m is nothing but the rate of change. So I can even call it a rate of change of x or slope of x1. Okay, and c is nothing but a coefficient which we add, or you can call it a bias. Here it is also the intercept in regression analysis, and it is the error rate. Now, similar thing is happening in deep neural net. Nothing fancy, nothing more sophisticated than this in reality. The only thing is this m has now become a weight. So what happens is, if you just look at an example of a house prediction, let's say a house is a bedroom square feet. I told you, I tell you to predict what should be the price of the house. So we have to predict Y, that is the price of the house. So you'll say, okay, what locality it is, does it have amenities, does it have how many bedrooms, what is the square foot, what is the neighborhood, and there can be 20, 30 more variables. Now, you had mx plus c, here we call this every variable of input as a neuron or an x, and we give it a weight, like your brain gives it a weight. And so here, rather than we giving it a weight, the machine will give the weight. So what is happening? Because I talked about universal approximation theorem. What is happening is I take a neighborhood, for example, let's say, and I feed in the data, and I'm saying that these many bedrooms, this square feet, this neighborhood, these amenities, the price is 20 lakhs, 30 lakhs, 40 lakhs, 50 lakhs. Inherently, when I'm training the model, I have not told it which variable to give a weight. It looks at the data and I've just labeled it. It might give weight to the neighborhood, looking at the historical data. And 0.5, 50% of the weight has just gone to the bedroom. Now, once you do this, if you look at it, what it is doing, it is summing the weight plus the neuron or the x, or here the bedroom, plus square feet ka weight plus neighborhood ka weight, and then adding a bias to it or the coefficient to it, and based on that, it is given summification. Let me know if this is not clear, guys. I mean, I'm not getting information. It's clear? Okay. So what happens? What happens is, once you have summed it, you give it to another layer. So typically, what happens is, let's say when you're making a forecasting, we go it by layer basis, and each layer's input becomes the output of other layer. And why this is very important is when you take an input of one layer and make an output of another layer, what essentially you are doing is you are actually making it learn more. And I've come to it, how does that happen? But out of one layer becomes the input of another layer. There is another trick to it. And the trick is that it not only sums, it uses something called an activation function. So let's say in a brain, what is happening is you're firing some neurons. If you see this diagram, in this diagram, some neurons are being fired. Now, which one to give a weight to? जैसे इस example में if neighborhood को ज़्यादा weight दिया data में, which one should give weight to? Will be based on activation function. So activation function is what? When you're doing y is equal to mx plus c, or you're trying to do some prediction, activation function allows you to add non-linearity. Because let's say I say, okay, we all know that speed is time member, but we can realize because you could have the environment variable, the wind resistance, all the people, the weight of the car, the number of people in the car, and there can be hundreds of more variables, all can influence what time you are going to reach your destination. That means you just can't take a simple model and say that, okay, you're exactly going to reach at that time. There has to be some non-linearity. The non-linearity is added here, A, for better predictions, and the more the non-linear it is, the better representation of the data set becomes for it to mimic the real world. Non-linearity is not a complicated word. I've exactly come to it how it works. So essentially, what we do is, if you look at this, diagram, we took certain x and we multiplied by a weight. We added a bias, right? And then we do, and we say, and that output goes to another. It becomes the input for the next layer. This keeps on happening layer by layer by layer by layer, and in the end, we say above predict. So let's say if I'm doing a prediction between cat, dog, snake, and let's say 10 animals. So I technically have 10 classes. The prediction has to be of all the 10 classes, and every class is competing for that probability. And the class with the highest probability is going to win. Now, obviously, you can set a threshold that anything above 80% or 90%, based on how much of data sensitivity and specificity you want to have, and the error rate you want to accommodate, you can mention that, okay, 95% if my data is accurate, if my prediction is, this is a prediction.
Nikhil, sorry to interrupt. Can you put it in the presentation mode as it is not visible to others, the PPT?
Okay, so sorry. Is it visible now?
Yeah, better.
Is it for all guys? Can you see the PPT?
So it's a very small version of the PPT that we can see, Nikhil, frankly.
Let me reshare. Let me reshare.
You can click on the slideshow.
Slideshow better, yeah.
Yeah, let's just hold on. Let me again do it, and I'm going. Actually, I minimized the PPT because I was also trying to be cognizant of the fact that if someone is typing something. Can you see now?
Can you increase the percentage? It is 64% currently. So if you increase the percentage, or can you select, so then it can be, font is very much, increase it.
Let me see now. Now?
Nikhil, just click on the slideshow button.
I think it is not coming to presentation mode or slide view mode. It is coming to presenters view mode. So there are two different things. So now we are able to see what the presenter should see while projecting his output on the projector, so that other people will not see the presenter's note or other details which the presenter uses for himself or herself. So the issue is that it is coming in presenter's view mode, not the presentation mode.
Okay.
See, you can, if you are using touch screen mode, you can zoom the screen on your own. It's nothing like if it's visible small. So you can just pinch the screen and it will zoom on its own.
Yes, it is doing that.
Yes, now it is okay.
Now it's okay.
Yeah, it's fine now.
Okay, so great. So guys, you know what? Now you guys become slightly more interactive. So otherwise there was a lot of void space. Okay. So now, okay. Now what you guys just did, right? You talked to me and you explained me. Now imagine if AI can do the intent. It can really do it. So as it understood the intent when someone spoke that your screen is not visible, or if you could just look at the image. You're talking about image, right? So if you look at the image, it is not coming. It can show you a notification, and then we can expand the screen. So these are the kind of use cases which we talked about. AI can actually do. So now you look at this image, right? So we take the output of one layer that by giving weights to each x. जैसे हमने वो prediction का किया था housing का example. And then it passes to each layer and it learns more information about it. And then in the end it predicts. And then obviously there is a loss. It has to be because it's approximating, right? Now once there is a loss, which is actual minus predicted. So you might say कि ये 80% cat है, but actually वो 100% cat. So there is a loss. Now you want to say, no, I'm not happy with the performance. We're going to train it more. So what happens is the loss will be adjusted across the layers. Because if there were 5 layers, so definitely have 5 layers, so उसको loss को adjust करो. Now in mathematics, to adjust the loss, when it is like layer by layer by, it is something called, it is a chain. So we had studied chain or partial derivatives, right? So rate of change is adjusted in each layer. So bear with me, only this part is anything, then all the fun will start. Okay. So now what happens is, in each layer, let's say I have to first, if you look at on top, the left, you see there's layer 1, layer 2, and then layer 3, and then layer 4. It is the single output, because we are just predicting some particular output here, and we call it y at here. And the actual might be y. So what I am doing is, I am actually, if you look at the equation, it is wi, mean layer 1, into x, so wi into xi. So all the xi to x3 or x4, they will be multiplied, and plus it is adding the bias. Now, Because I said once it has summed the first layer, it has to also give it a masala. That is non-linearity. जैसे मैंने कार का एग्जांपल दिया था, राइट? वो एग्जैक्टली टाइम पे नहीं पहुंचती. There is certain non-linearity to represent for the representation to happen. And we call it an activation function. So the उसके next वाला जो equation है, that is an activation. So what we do, that G is nothing but it is just a symbol for activation, and I'm activating it through certain equations I'll come to, and I'll put the complete summation of that into the of the Z variable in it. So जो भी मैंने W weight into X plus bias किया, उसको मैंने एक activation function के अंदर डाला. अब next layer में जो input होएगा, that is the output. So obviously, if you see that was AI, so now in the second layer, that is Z2, weight is multiplied by A1, and it keeps going on. Now, obviously, in the end, it will predict Y, and when there is a loss, if you see D by Z is nothing but it is all of these equations are partial derivative equations to adjust the rate of change over layer by layer. So if you look at it, it's actually just doing summation, activation, and then loss calculation, and then adjusting the loss. Now I repeat it: summation, activation, loss calculation, and then adjusting the loss. That's how deep neural nets are formed. And जितना बड़ा neural net है उतना better. अब वो activation function use यार आपने बता तो दिया ये है क्या क्या. So there are a lot of activation functions, and it is all by trial and error. We know which works, which don't work. I'll first come to a more simpler activation. That is called ReLU. This we are going to use right now in image processing. So ReLU नाम बहुत बड़ा, rectifier linear unit, काम बहुत छोटा, but simple and elegant. Basically, when you have to detect an chua, so obviously you're going to slide like a torch. So you will take a box of pixels. We call it convolutioning, and we are trying to check different areas. And while we're checking, we are multiplying it, right? So now what happens is, if I have to detect that edge, the back edge, what I want is there will be when you look at an image of a rat, or if you look at any other image, there will be a lot of background information, unnecessary information. If you're just looking at the back of the rat, there could be the garden, there could be the tree, there could be other color contrast happening. So a lot of things can happen, and you are not interested in that. You say, I just want to know the back of the rat. So let's say you already have a learned representation. If you already have a learned representation, like a template of what a back looks like, think it like we call it a feature. Now that feature map is on the right here, like a matrix. Can you see this 30, 30? Can you tell me the rest are 0? Can you tell me how it looks like? 30. Can you see this? Is it visible, guys?
Yes, sir.
Yeah.
Now, as you see 30, 30, 30, 30, 30, and rest are 0. Anything multiplied by 0 will become what?
Zero.
Exactly. So imagine all the background information of गायब हो और जो बचा आपके पास वो बचा 30, 30, 30 मतलब सिर्फ पूंछ बचा. This is called an edge. Now what is going to happen is this is how computers are calculating the edges. They are multiplying with certain matrix, and irrelevant information is being nullified, and the relevant information left. That's the ReLU is called 0 and max. Then there are certain more functions like sigmoid. Sigmoid and softmax are two functions which are also very important. They are used for basically in the end when you want to predict the probability. Because I told you that every class is fighting for a probability score. Dog will say, no, I am the dog. Cat will say, I am the cat. But probability to 100% ही हो सकती है या 1 ही हो सकती है. Now, obviously, the probability score will rise from 0 to 1, or in percentage terms from 0% to 100%. So anything divided by 1 will actually reduce the 1. And so that is why if you see, when I do 1 by 1 plus e to the power of wx plus b, weight plus bias, फॉर्मूला को भूल जाओ. यू सी जैसे जैसे ऊपर जा रहा है 1 के पास आप देख रहे हो ये s बन रहा है, मतलब सिग्मॉइड जो फंक्शन है वो फ्लैटन हो जाता है. सो दीस टू फंक्शंस यू हैव टू रिमेंबर रेस्ट योर. नाउ वी हैव अंडरस्टूड द जादू ऑफ ReLU, and now we are going to talk about the most exciting stuff that is coming. And now we are going to mimic the eyes and in the how I see and how we are like artists. We can create a computer vision, okay, from a human vision. So 550 or 600 million years back, there was an explosion in species. Obviously, because you would have guessed it, it was because of um, we rudimentary vision. Species started building the periphery vision. So sea life started having periphery vision. They used to see some blur in their eye cones. RGB was not that perfect, and certain image was being formed in the brain, in the area of visual cortex. But because of that, it was an explosion of species. But how do images are seen? So this is very interesting here. If you see that, you see a basketball, and if you see the left image, can you see the basketball is easily visible? But if you see the second image, you can still figure out it's a basketball. Although the color has gone, but only through the edges you are able to see. But if you look at the third image, you can still figure out it's a basketball because you can still see the context that एक गोला है और वो basketball court पे खड़ा है पे रखा हुआ है. Definitely you will make a logical context, a leap to your visual information processing that no, that is a basket. That is most likely a basketball. It could be a football also, but most likely a basketball in a basketball. Now teaching this to computers will be similar. So what happens is we are going to break this image into shapes, into pixels. Every shape has got a pixel. Pixel has got a value, a mathematical value, and that pixel you can break, and they can be, let's say, आपका image है, when you click on your phone, iPhone today, it has got 1024 by 1024. Or it's HD. It can even be 4000 pixels by 4000. But imagine 1024 into 1024. If you calculate the number, it is more than the stars in the universe. But imagine if you do 1024 into 1024, and then you also have RGB information because red, green, blue form the color combination. So now imagine the number of combination that can be formed. लेकिन अगर आपको अब यहाँ ध्यान से देखना, left image जो top पे जो image है, there are certain edges. Those edges, when I club them together, they make body part. We call it a feature. And that body part, ear, nose, I can add together, they make a face. But each layer, जो input से output बन रहा था, वो किस edge को weight देगा, किस edge को weight देगा, और किस neuron को fire करेगा, वो ये neural net training के वजह से. So that is why I wanted a little bit of maths to come so you can appreciate it better. So in the end, it will predict. And predict के लिए it will use the activation function software. और ये edge को कैसे निकालेगा, जैसे हमने चूहे की पूंछ निकाली थी using REM. Okay. Now, how traditionally we used to do. Now you can see these three images. Two people standing in a tie, and then you have also in the rest two images. Now what happens is, if you see, when if even as we discussed about edges, as we have removed the edges information, you can see that you are still able to make out whether वो human है कि नहीं और पीछे activity. Yes or no?
Yes.
Even in the last image, you are able to do that.
Yes.
So what पहले वो laboratory में lab में क्या होता था? People used to find this Adobe Photoshop में जो filters है वो ऐसे बने. So we used to take this matrix and ये matrix को we trial and error. ये नंबर देखो, ये नंबर लिख के देखो और देखो एज बनाता है कि नहीं बनाता, कर्व बनाता है या वो डायगोनल, हॉरिजॉन्टल, वर्टिकल कैसे टाइप का एज बनाता है. ऐसा कर करके हमने एजेस डिस्कवर किए. लेकिन प्रॉब्लम का वही, हर नया डेटा सेट के लिए क्या हम नई तरीके के परम्यूटेशन कॉम्बिनेशन ढूंढेंगे तो वो तो मिलियंस ऑफ कॉम्बिनेशन है. तो नाउ डीप न्यूरल नेट बोलेगा बॉस जादू मैं करूंगा, तू मुझे इनपुट दे दे, आउटपुट लेवल बता दे, वो अप्रोक्सीमेट किस पिक्सल को कितना वेट देना है, मतलब ईच पिक्सल इज एन एक्स इज एन न्यूरॉन हियर, कितना वेट देना है और किसको एक्टिवेट करना है, ये मेरी जिम्मेदारी, आप भूल जाओ. So now it has become very beautiful and elegant to solve it. Rather than a rule-based approach, it is an approximation. So I take an image, I deconstruct the image into pixels. Each pixel has got an X, which is a mathematical number or a weight. It has got a RGB information, or if it is gray, it has got a single information. It can even have, if it's a 3D image, it can even have a depth. And then we are multiplying it by matrix. So if I look at here in the matrix, फॉर एग्जाम्पल आई हैव टू दिस फिल्टर, इमेजिन करो वो चूहे का फिल्टर दिखा था जो बैक क्रिएट किया था, उस फिल्टर को उस एज को निकालने के लिए लेट्स से फिल्टर था -1 -2 1. Now I multiply this with each pixel. So let's say there's 3 here. I'm going to multiply. You can see the calculation. -1 into 1, 0 into 4, blah 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 blah, and it comes as 7. And edge is nothing but the rate of change of contrast. So whenever there is a rate of change of contrast, the edge forms. Guys, I'm trying to simplify it a lot, and I could have easily gone without a little bit of mathematics, but I just wanted to push it just to give, so that now you can now when Sachin will walk you through the visual how we have built Asia's first visual AI platform. You don't need to do all this, but now you can drag drop and understand how layers are formed. So let's say ये cat की image ली, हमने cat की each pixel को 1024 into 1024 पे एक डब्बे में डाल दिया, each को x0 to x 12,000 कुछ वैल्यूज है, each को वेट दिया, एक एक्टिवेशन फंक्शन दिया और इसको अगले लेयर में पास कर दिया. हर लेयर पे वो उसका एज को डिटेक्ट कर रहा है और उस एज से जब वो हम उसको कन्वॉल्व कर रहे हैं, मतलब जो ये स्क्वायर टाइप मल्टीप्लाई करते आ रहे हैं, उस एज से वो कुछ इंफॉर्मेशन निकाल रहा है और ईच लेयर में फिर वो उसको उसके बारे में और समझ रहा है. तो सम ऑफ एजेस बिकम फ्रॉम पार्ट बॉडी पार्ट एंड देन in the end you can see here it is calculating कि ये bird है, dog है, cat है, क्या ये probability है. There is only one more thing I want to add here, and this is sense of humor. So Jeff Hinton, everybody was very happy, but उसने ऐसे arrange कर दिया हमारा face. अब वो तो edge detect कर रहा है, edge detect करने के बाद जब ऐसे face arrange कर दिया तो भी वो उसको human बोल देगा, because ultimately I told you starting with there is no general AI in the world. At least today, that's an aspiration. It's a local AI. So there are methods to solve this also by including the positional information. It's called capsule network, which we are not going to cover. But I hope, guys, please tell me. I hope now you might have found a little bit of, but how? I hope now you've been able to understand key behind the scenes.
Yes, some basic idea.
Great. So now that we have done this, now we will walk through the actual demo. And here you can see, we can label the data. Like ये लाल is pimples, red is no pimples. ये पहले label करते हैं and फिर वो काम करते हैं. Now, some example, if you see, it can be used in cars. It can be used to detect emotions. It can be used to detect bills. तो लेट्स से आपके पास OCR आज की डेट में आपने देखा होगा, जैसे ये है, मैं बिल से इंफॉर्मेशन एक्सट्रैक्ट कर सकता हूँ. तो ऑल ऑफ देम देयर आर प्लेथोरा ऑफ एग्जांपल्स. So this is about computer vision. Now for 20 minutes we will show you a magic where you don't need to do any of this. You need to just have this intuition, but just by drag and drop अपने आप की कोई भी आप वर्ल्ड का डीप न्यूरल नेट का कोड लिख सकते हो या मशीन लर्निंग का. So over to you, Sachin.
Thank you so much, Nikhil. So now as Nikhil has briefed you about the evolution of artificial intelligence, about vision, the training, so we can conclude that the present era of artificial intelligence is all about teaching or training the machine. So today we will mimic the vision into artificial intelligence. So we will build and train a deep net to create a binary classifier for mask detection. So let's first quickly run the project. So this project basically tells you whether or not you are wearing a mask. And as you know, in this COVID scenario, it can be very helpful for shops, malls, and etc. So as you can see, it is showing in the red box if you are not wearing a mask. And if you wear one, it will show you in the green color. So today we will make this particular project. And one more thing, if you observe carefully, it is showing a percentage at the top. Now what is the percentage? So it also means that percentage is equally important in a particular project. So it also depends on project to project. Although, for example, it is okay to have 90-95% accuracy in project like these, but when it comes to project like self-driving car, we can't just let it go on the road with 90% accuracy, because in that case it will mean that it is killing 10 people out of every 100. We just don't want that. Anyways, So now, as you have seen the project which we will build today, so the next question is how. And someone earlier in the chat wrote that it's too much of math. But the platform which we'll be using today, you don't need to remember any math. That is the beauty of that particular platform. So now, creating an AI project is like baking a cake. Now, how you bake a cake? There are several steps, which is collecting the ingredients, then mixing the ingredients in right proportion, then pouring the batter into the mold, which basically tells like how many layers or what will be the shape of the cake. And the next step is baking the cake in the oven. Then we have inspecting and checking that whether it is baked properly or not, and then decorating it, and at the most important step, which is tasting. So these steps we can follow to build any AI project. As you can see on the screen, on the left side, it is the steps of baking a cake. Then on the right side, it is steps of creating an AI project. It starts from loading libraries similar to collecting ingredients, and we go all the way down to testing our trained model of that particular project. So without any further delay, let's start building it. So this is the platform I was talking about. I will brief you about this platform at the end of this webinar. But for now, just let's start working on it. So what was the first step? First step was collecting the ingredients or collecting the libraries in AI project. So as you can see, we are dragging the libraries block like matplotlib, which will help us to plot some graphs. Then we have NumPy, which will basically help us in computation. And one more thing you might observe over here, that when you are dragging a block, the code automatically appears on the right side of the screen. So you don't need to remember code, you don't need to remember math. All you have to do is drag and drop, drag and drop. That's it. So now, what was the next step? The most important step is data set. As this particular project tells you that whether or not you are wearing a mask, so the data set also needs to be related to that only. So we have a data set with two classes, which is the binary classifier. So as you can see, we have two folders, and in the first folder we have images of person wearing a mask, and in the second folder we have images person not wearing a mask. So we'll just feed in these images, tell our network, our model, our machine, just learn from it. Okay. So in the second step, we have seen the data set. We have loaded the data set by just the first block. And now one thing you might see, there is something called target image size. Now, why we are doing target image size? See, when baking a cake, you have to mix all the ingredients in the right proportion. You can't just add more sugar, then it will just ruin the cake. So similarly, when doing a project, you have to maintain a uniformity across the training of the project. So here we are just taking out the images. We are just converting them into a size of 224, and 3, which is basically length, breadth, and the number of channels in the image, which you know as RGB images. So we have just done it over here. Now next, if you carefully see, there is something called data split into train and test. Now I will ask you guys that why we are splitting between train and test. So can anyone answer? I'm waiting on in the chat box. You can write in the chat box. So okay, so Varun has returned that so the train model can be tested. That's absolutely right, because the test data set contains all those images which our model hasn't seen yet. So in that way, it will tell us how accurate our particular model is. So that's why we are splitting it between train and test. And then we have a block where we are just shuffling the data set. So then now, what was the next step? Was pouring the batter into the mold, which basically decides number of layers on the cake we want. So similarly, here also we have to decide how many layers of architecture, how many neurons, as Nikhil has already explained you what neurons are, we require in our network. So here we have already created a 4-layer network. So which are basically we have two convolution layers, and then we have some dense layer. And you carefully see in between those, there is something called activation function. As Nikhil already told you about ReLU, and here also we are using ReLU. And the thing
to interrupt. So what Sachin, like he's talking about ReLU here, right? The same thing to right wala phone star. Now at every layer, you are there the input, the output which is coming, it is and the ReLU activation function is making it learn something. Certain information about the edge, certain intelligence, which it will carry forward and then use it while it is doing a probability in the end. Go ahead.
Thank you, sir. Thank you, Nikhil, for the input. So each layer, as Nikhil has already explained, that it will remember, it will extract some different features with the help of each and different neuron. So now, after we have created the layer, I want you guys to look at the last layer. Here we have only 2 neurons. Now, can anyone guess why we have 2 neurons? Anyone? 2 classes, right? So because it is a binary classifier and we have only 2 classes, whether a mask is there or not. That's why we have to enter 2 as neurons in the last layer, which is same as the number of classes. And at the last layer, we have to use sigmoid as our activation function, because it's basically used in cases of binary classification. Now that we have created the network architecture, we have loaded the data set, we have loaded the libraries. So what was the next step? Can anyone guess? If I just give you context, in cake it is baking the cake. So what can be the step next here?
Training.
So, yeah, training. Very good. So next step is training the model. So we are using these bunch of blocks over here, which will basically help us to select the loss function, which Nikhil was explaining. Like it will go forward in the network, then it will check how much loss it has caused for that particular epoch. Then it will go back again. So these blocks are basically helping us to select those loss functions we want, those optimizers or number of iteration, number of epochs we want to have in the architecture. So now here it is 2 epochs. Let's just change it to 10. So now we have completed almost all the steps. We have created the architecture, then the training is almost done. Now one step which is required, that we want to observe, we want to see, we want to visualize how our training went during the process. So for that, how we can achieve that? By plotting some graphs, obviously, because graphs are easy to interpret. So here, these bunch of blocks will help us to plot some graphs of accuracy and losses. Then we will get a confusion matrix also. And at last, we are just saving our trained model. So that's it. This was the whole project of Masketon. Now the next step is to train it. We have just connected all the blocks. Real training is still left. So
Second, before you train it, just spend one more minute and for everyone can visualize and maybe go layer by layer just once. Okay. So first we loaded the libraries. This is good as well.
So can we go to the full screen mode at the right top? Yeah. Now it is clearly visible, and we can just also zoom it a bit. Yes. So let's go through from top to bottom. So at first we loaded few libraries, then we loaded our data set and did some pre-processing. Then we created the architecture with 4 layers, convolutions and some activation layers, dense layers. After the layers, what we had to do, we had to train it. So for that we used this compile and fit block. And at last we wanted to visualize how our training went. So that's why we are plotting some graphs. So that was the block code. Now it's time to run it. So let's just run it. Now these models require high computation power of GPUs, CPUs, which is also expensive, as Nikhil was also saying. So Google already provides us with free GPUs and CPUs. use for our model training in the tool named as Google Colab. So why just waste the money and when we can use the free GPUs and TPUs for the training, or why to train it on our own system? So here we will click on the Go to Colab button. It will redirect us to the Google Colab, and then we will create a new notebook. Now, the thing is, the code which we have created on the platform got automatically copied. So all we have to do is just paste it in the cell. Let's first let it run. I will let it load. Yeah. So we'll just paste the code over here. Yeah. As you can see, all the code appears. Now the next step is training it. So basically running it. So we'll just click on run. As you can see, it is right now connecting to GPUs and TPUs resources. Then after that, it will start to run. So if you just scroll down, it is successfully connected. And now, as you can see, it has started to run. So first, it is loading the data set. After loading the libraries, now it will take quite a few time to run it all. So we already have a notebook where we have already run it. So we'll just show it to you with step by step. So as you can see, the first steps were loading the library. Then we were loading some data set. As you can also see the few images of the data set with mask and without mask. And the next step was reprocessing. We did already pre-processing. Then we created this particular architecture using those layers. And the next step was
Sachin, one minute. Can you just go back to the architecture just above?
Yeah.
So guys, what you did visually, you created the architecture, and what all functions you use. All this, the notebook shows you like this. Okay. Now you can go ahead. But the main idea is that while this is being training, because we don't want people to get scared and afraid of AI, because it's more intuitive. The power is that this drag and drop allows you to understand the intuition behind it and be empowered to solve your own AI use cases, whether it's deep neural net based or machine learning based. So now you yourself can have fun with it in this way and build any kind of a network you want. Go ahead, sir.
Yeah, thank you. So we don't need to follow this particular architecture. We can create any of the architecture we want. So after creating the architecture, we trained it. As you can see, we have trained it for 10 epochs, or we can say 10 iterations, and we achieved the training accuracy of 95% and the validation accuracy of 90%. So after training it, what we did, we plotted some graphs. So as you can see, it is more clear how our training went, that like the loss is decreasing and the accuracy is increasing. Then we have confusion metrics as well, which will basically tell precision and recall stuff. So at last, we just saved the model. Now, what step is left? We have trained it, we have saved it, but what we haven't done is we haven't tested it on camera. So how we gonna do it? So when you run this particular notebook, automatically one zip file will download it on your system, which basically contains the trained model. So as you can see, we have already the trained model in a zip file. So now we will just go to the project which we were on earlier, and we will just upload our own model. So as you can see, we have upload button. We'll enter a name, and then we have to select the trained model files which we got from Google Colab, and we'll just upload it. Will take time depending on the size of model. So and background color got changed over here, so it means it is successfully uploaded. Now if we see that if it is working, so see it is working. Right now it's showing in red color that it is not wearing a mask, and if she put it on the mask, it is showing in pink color. So that's how you can create your own model. You can design your own architecture. You don't need to remember any syntax. You don't need to remember any math. All you have to do is drag, drop, drag, drop, drag, drop. And that's how you can test it on cameras and all. Now,
One more thing, Steve. So, so folks, the mission of Funoppia is not that one should not learn logic, or because this requires still a lot of creative thinking and computational logic. We have both the code window, so if you're comfortable, you can still write the code. But most people get left behind in the field of AI or in the field of computer programming, just because there is an initial itch. So this not only acts as a bridge, but this bridge is itself sophisticated enough to handle any kind of machine learning, from basic regression analysis to unsupervised learning like support vector machine or K-means clustering, to deep neural net or NLP tasks. So whether you want to create a chatbot or anything. So the idea is that with drag and drop, you see the code also, so that you can visually, as information, intuitively understand that how the code is being formed. But you don't need to be restricted to it. You can just now also reduce the time. So if it used to take 1 week to write a code, now you can do it in a matter of few minutes once you get comfortable with it and you build a visual intuition. So the visual intuition is very important. Like Einstein used to say, imagination, and that's the reason which is the genesis of Funoppia.
So Nikhil told you that we can also run machine learning algorithm, and I also promised you that I will brief you about the platform and plan. So let's just see what else we can do on this particular platform. So we have few ML algorithms, linear regression, logistics, KNN, then support vector machines and all. So we have, to save time, we have just loaded a already prepared linear regression notebook. So what linear regression is used for, let's first run it. So it is basically used for prediction and forecasting purposes. Like you can do weather forecasting, you can predict the price of shares in the share market, then you can predict marks of students based on some certain features, certain parameters. So here the data set is about which is experience of a salary, like how much salary you will get based on the experience you have. So it is a simple data set, and we have run the linear regression over it. Then you can see we have some accuracy of about 83%, and we also have a graph to visualize how our training went. You can see how well our line fits on this particular data set, which is just a sample data set. Now you already, and one more thing I would like to point out is that you can also type your own code. If you got fed up with blocks that I don't want to use, you can also write your own Python machine learning, deep learning editor itself. So if you just write a print statement, so all you have to do is just type. You have to use the Python syntax. So if you just run it now, see, there is no block, but it is also it is still running because it is now running the editor code. So you can also do that here also. Then we are already aware of the project playground. So let's go to that as well. So here you will find already made projects which you can do on this platform, and not only this, you can create as many as you want. And apart from these projects and all, we also have a teacher training program which is for those teachers who want to learn Python or AI. We have different classes for different courses. So, and one more thing I would like to tell is that each class over here is divided into certain small capsules, which is of around 6 to 7 minutes each. For example, you are seeing on the screen right now, it is a journey of a class called conditionals, where you will learn if-else concept. So as you can see, we have there is a takeaway that what you will learn in this class. Then we have small capsules, 8 small capsules over here. We will start by learning the concept using the game. So we have a game, for example, this bird game, where we have to guide the bird to carry the worm and go into its nest. We have to use the concept which is if-else. So here you will learn the concept, you will learn the intuition by playing some games. Then we move on to learning and solving some other real-life problems based on if-else. Then we will create those projects, and at last we will create one dedicated project based on the concept which is developed over here. And not only this, you will also get to know about the flow of how the program is going, how when basically the control flow of the program, and at last we will have some assignments and quizzes. So each class in the course will basically we have this kind of journey. There will be some capsules and there will be some takeaways.
Yeah.
So
One here that using the ID, anybody can use the ID. It is nothing, not restricted to the course as such. Because we want to keep the learning as open as possible. So unless if you don't want any personalized dedication, you want to do it on your own. The Funoppia ID, you can create a register your login, play around with it, play with the projects, create your own projects, as well as there are pre-built help files also, which are already present inside. So every block, if you right click, you would find that it has its own help, text and video both built into it. So the idea is, unless you really want and you just want to go into self-discovery mode, most welcome people can use, because the mission is as many people as can get into the AI revolution and cognitive computing revolution, the better it is for the society. any questions, guys, about the AI or the learning methodology or Funoppia as a platform which we talked about?
yes, good.
Yes, good question. They can use the platform free of cost. The reason is we want to be an honest company where we can facilitate and synthesize education without charge. We want to be the forefront of doing that. So the platform is absolutely free. You can be on a self-discovery mode only when you want a dedicated teacher. You all are teachers or educators, you understand it. There is a cost for that which we can't subsidize. I mean, we have subsidized, but there is a cost to that. Otherwise, or a teacher training course specifically. Otherwise, if you want to do a self-discovery, take it like an AI operating system. You guys can go log in, play around. There are videos, there are help files, there are projects, and you can begin the journey.
So, Nikhil, thank you for that. I just want to make one clarification. That means if the teachers want to go into that self-discovery mode and want their students to use this platform, they can do that as well, free of cost. So, something like code.org, where you have the activities, you go, you play around with that, and you can use it in your classrooms as well.
Absolutely. Okay. Because our mission is holistic in nature. It's only when a student says, "No, I want more than that. I want a dedicated teacher, or maybe 3 or 4 students in groups, or maybe teacher I want to have a more professional rigor to it." Then we say, "Okay, for that we'll give you a dedicated expert who is going to handle you." Otherwise, please jump into the revolution. We want as many people to celebrate it.
Sure. Thank you, Nikhil. Thank you for that.
Yeah. I also think, we also have Professor Pant and Professor Ramesh. I think so Professor Pant and Ramesh have been our mentors who have been guiding us all across and pointing us where we were going, where we had to correct ourselves, as well as where we were wrong. So I think he's here. Professor Pant, thank you for joining. Any wise or wisdom words from you in the end? Professor Pant, can you hear us? Okay, maybe he's on mute.
Yeah, he's on mute.
Okay, no issues, guys. Any other in the meantime? Anyone else has any doubts? So Shubham has said, thank you. So everybody can go and create their own logins, and if you have any doubts, you can reach out to us over the WhatsApp or contact us both by informal, formal methods. We are fairly approachable and accessible. And in case you guys want to know anything more, please reach out to us anytime. Gurpreet, you have been, I saw last time, ma'am, that you have been doing computer vision and you have taken a session also at Worlds to explain the basic. So, do you think this kind of platform would be beneficial for your students?
Yeah, definitely, Nikhil. That is why, I was just typing in the message, so I stopped. I said, okay, let me speak it out only. I think, first of all, I want to congratulate the team because I always used to wonder why is it that we have code.org and all these platforms all coming from American brands and here and there, and why nobody in India is building something like that. So congratulations for you to you for that. And
Thank
second
you.
thing, I am a very big professor of free learning resources. So I think as soon as you mentioned that, I am the first one who will go and tell the schools that here is one platform which can offer you free resources and you can explore, and you have to become a self learner because that's the way we have to nurture our kids now. So
Absolutely, and that's the way. So only when and we for us also it's a tricky thing, right? Because there's no government support, so we have to see
yes,
how we keep it as much as we can, and yet have a model where it is sustainable.
absolutely.
Uh, so that's it. Thank you for the thoughts. And yes, we want it to be not only first in India, but by the way, this is first in Asia where it's drag and drop AI. So Scratch and all you can do basic stuff, but this is actual artificial intelligence and statistical modeling and machine learning with drag and drop.
So kudos to you and your team for that.
Thank you.
Okay. Anyone else? Any questions, guys? Thank you, Ajit. So actually, may I know? Okay, someone has written Banana Gaming Brawl Stars. Okay,
This is
testing.
Rashmi actually.
Yeah,
Hi, Sachin.
hi, Rashmi.
Yeah. So
Go ahead.
I
So
have
you,
posted.
please. Your question is, how is AI beneficial for educators and what platforms are available to support?
Yeah.
So, go ahead. Yeah, you were saying something.
Please go ahead. Please go ahead. No, I'm just listening.
Yeah. So, see, any skill in itself is never complete, in a life journey. But there are certain skills which have become very important if you really want to, specifically in the digital age. AI is one skill which helps you to do a couple of things. One is not only build computational thinking and logic, but uh, it empowers you to solve a lot of problems which not only you can do it on through computers for commercial gain, but even which humanity is facing. Just to give you a context, to do a COVID drug discovery vaccine, uh, every big company in the world was running actually artificial intelligence to actually computer understand which molecules will bind better with and which target therapies will work. It's a similar case, climate crisis. Say, like, even if you want to teach your students, there's a company called Max Education with personalized learning through artificial intelligence. So what they did is they took the data of the kids and based on the kids' data and how they learn, they built an adaptive learning model using Bayesian optimization techniques. So the point is that AI is a skill set today, gives you superpowers. That doesn't mean you solve your problem for yourself. We as humans have to use our own creativity, and we all know that we have to go and to the streets and to the ground and field work to solve the real problems. But it does give you competition tools to analyze, and it does give you competition tools to focus on more creative stuff because you can automate the redundant stuff, or you can automate the stuff for which which is a lot of time consuming. So AI for educators is very necessary, specifically even after this might sound a little cliche, but even after CBSE and NCRT mandating it, but globally it is happening. What we feel India is still not there, and that hurts us, and that's why Funoppia genesis was. Because if you look at China and any other nations, they are thriving on the AI wave today. Indian startups are there, they are existing, but they all are going and solving some nitty gritty problems from the consumer demand side. I think educators will play a very important role for shaping the kids using artificial intelligence by creating adaptive learning models, by personalizing the curriculum and automating the tasks which actually should not have been, which are redundant. For example, removing bias, checking papers, and all that stuff, and facilitate learning through bots, so that they can pose a more experiential and more multifunctional. And even if you're not an educator, as a person, I think if there is a skill which you should, two skills which are very important today. One I think is design thinking, because aesthetics and humanistic inspirations to create more organic designs in the world. Another is AI. Are two skills which will remain the skills of the decade, no matter from whichever industry you're from.
Great. It sounds great. Am I audible?
Yeah.
Like what you have talked about as like this site Maths Education, did you say? Can you just post it on the group also? And because see, our students do have learning gaps, and the one you are talking about, the adaptive learning, what this site offers based on the data of what students are learning, it really sounds great and sounds helpful also. But I don't know what they are going to charge or anything. But then, what you as Funoppia has to offer in that case, I'll be more interested in that.
So we as a they offer a particular how to do adaptive learning as a service. Funoppia is an open platform. We are a community of AI researchers and developers who have built this platform where there is no drag and drop tool today through which you can build artificial intelligence and machine learning. So you have to understand that if you today have to learn AI and do it yourself, you're not empowered for that. And service you can even via Google today. But if you really want to become a creator and not a consumer in the economy, then how could you jump into the creator revolution? That is where Funoppia pitches in, where we have given Asia's first drag and drop, where you can just through visual intuition create your own AI models and celebrate automation and see, and also along with your video classes, jump on to creating and solving new problems. So AI is far more open and fuzzy in that way, but at the same time, it has a visual AI platform. As a visual AI platform, you're free to create anything. And on top of that, we have got a structured curriculum also. So let's say you say that no, I want to go beyond this and I want to learn. Sure, then we have a structured curriculum where how you could empower yourself and let's say become and learn about in depth about computer vision or NLP. That is taught, whether that is to kids or whether that is to teachers or whether it is to anyone.
Okay, and how about coding? Is that a part of being efficient in this AI?
No. So we do teach coding, and like Sachin covered, they were games, right? And the games have been intentionally built to be like a spiral learning and a reinforced learning, where the concepts are installed. But coding, even see, that is the power of the platform. That you have coding and you have visual both. We teach coding also, but if you say no, I don't want to do coding, I just want the visual part. You're most welcome. You can do it. So, and is coding a prerequisite? No, absolutely not. Because people can come from different background, from liberal arts, and we don't want to distinguish whether. So, obviously, there are certain levels. So, if you already have an existing coding experience, then you are put on a separate track. If you are not from a coding experience, you are put on a separate track. Either way, none of their learnings will be a barrier because of the visual interface. So, today, do you have visual interfaces? You do have, like Preet was mentioning, you have Scratch and all, or Code.org, but they are limited to very child play and for to early education. But if you really want to create problems which are more sophisticated, like you did mask detection, or you want to do a facial recognition, or you want to do a summary analysis of NLP, you need to have more sophisticated model, and there having a visual model will help you to adapt a skill faster, learn faster, and learn coding. But you might not want to do coding. You might just want to be on the visual mode because you're more comfortable now. It's as good as driving an automatic car and driving a manual drive car. It can be a part of preference, but people who really have a sense of fear of control, they can leave it to the automatic people, to take it forward.
Okay, and maths knowledge won't be a barrier, as Sachin sir had mentioned, that it won't be a barrier that if you are not good at maths that way.
Maths definitely evokes a sense of fear in most of us, right? And I have known my nemesis about it, and we try to make it more like poetry. But no, it is not a prerequisite because we only cover that much maths, and that too visually, and that too जैसे मैंने आपको अभी the बहुत complicated function नाम था ReLU, rectifier linear unit. But I just told you anything you multiply by 0 will become 0, or जो बचा, that is the area of interest in that image. Now, honestly speaking, the amount of maths that is there required is not that much as what people comprehend to be. So we simplify. We don't only have a platform, but we have a complete lesson journey. So code.org, you don't have lesson journeys. So once you join the course, you have a personalized lesson journey. In each of the lesson journey, every story, every concept has an abstraction, has an application, and has a visual story to it. So maths is not going to be a barrier in short. Okay,
Thank you. Thank
any other questions? All right, guys. So we will send some logins, and thank you for joining, everyone. We hope you love the platform, and we wish you all the luck. And we would be more than happy to assist in any way. Join the learning revolution. Join the AI revolution. We really have made a lot of effort to make it as simplified as possible by creating a visual platform for it. Thank you, everyone.
Yeah, thank you, sir.
Thank you, sir.
Thank you very much.
Thank you.